Let us see how to use a feature called as component test available in this CRO. This feature can be used to obtain VI characteristic of a given device. Before you start using this feature, you should know how to enter into the component test mode. This process is different for each of the CROs. In this CRO, this process is something like this. There is a button called as X5. Next to it, they have written something called as CT, which indicates component test. To enter component test mode, we should press this XY button. So the oscilloscope goes to XY mode. To make sure that our readings are proper, I'll make sure that this dot coincides the origin. I'll choose this point, the center, as the origin. So using position adjustment, I'll bring the dot to the center of the screen. Once this is done, as per the manual, I'll have to press another button that is present here. It is also indicated as COMP, which stands for component. So I'll have to press this button. The moment I press this button, and one more thing what I have to do in this particular model is to press this invert button. Once I press the invert button, the trace may not be centered on the screen. It may go up or down. I can use channel Y position adjustment knob and bring it to the center. Once this is done, we are ready to obtain VI characteristic of any given device. I'll take as an example a simple resistor. A resistor is a two-terminal non-polar device. That means it has no polarity, plus or minus. So we can directly insert this into the component test port. So they have written test in over here. So you are supposed to affix your component into this particular port. So I'll put the resistor into the port. So component test port. Now CRO displays VI characteristic of resistor. X-axis is the voltage. X-axis or channel 1 is the voltage. So they have written X here. So this is the voltage axis, X-axis. And this channel 2 is the Y-axis, that is the current axis. You are not supposed to read this as voltage anymore because this is representing current axis. Even though they have written V here, they have also indicated that under component test, in this component test mode, this will behave as current. So I have set the position to 1 milliampere. So this is 1 milliampere. This is 0.5 milliampere, 2 milliampere, and so on. So let us see how the VI characteristic of a resistor looks like. Resistor is pure resistance, so its VI characteristic is a straight line passing through the origin. If I change the resistance, from 1 kilo ohm to 2 kilo ohm, I'll put 2 kilo ohm resistor here. This is the VI characteristic what I obtain. If you can observe here now, if you calculate the slope, I'll take this 2 volt and current is 1 milliampere. So if you calculate resistance, R is equal to V by I, 2 volt divided by 1 milliampere will give you 2 kilo ohm. So this is the VI characteristic of a resistor. Similarly, you can use any polar device also, but polar devices will have positive and negative anode and cathode. You'll have to do some experimentation to figure out how you should insert the device. So this is a diode. It has anode and cathode. I'll put the device here. So this side is P type, this is N, this is P. It's a diode. Now let us see how the VI characteristic looks like. So this is the forward characteristic of the diode. I'll change the scale. I'll make it 0.5 volt. So x-axis is 1 division is 0.5 volt. So if you observe, this is the origin and this is 0.5 volt and 0.6, 0.7. Current is rising exponentially. This is a silicon diode and this is how the forward characteristic of a silicon diode looks like. Let us obtain VI characteristic of another diode. So I'll remove this diode. I have one more diode. This is a point contact diode. So P type goes this side and N goes this side. And this is how the VI characteristic of this particular diode looks like. You can ignore this flyback trace, the leftmost trace that is coming because the electron gun is going back to the leftmost position, its starting position, so it is created because of that flyback. So it's called as flyback trace, and you can ignore that. And this diode has a new voltage is very less, it's almost closer to zero, and from here current is rising exponentially. This is the VI characteristic of this particular diode. Now let us see how VI characteristic of Zener diode looks like. I have a 5 volt Zener diode, that means its reverse breakdown voltage is around 5 volt. I'll insert the Zener diode to the port, component test port. So this is how it goes, and this is how the VI characteristic of a Zener diode looks like. Its new voltage is somewhere near 0.5 volt because I have set the scale like that. So 1 division x-axis is equal to 1 volt, so it is somewhere near half of that, so it is around 0.5 volt. That is the knee voltage. The Zener diode breaks down, its reverse breakdown voltage is somewhere near minus 5 volt. This is 0, so from here if you count, so it is somewhere around minus 5 volt. So this is how VI characteristic of a Zener diode looks like. Not just diodes, you can also obtain input and the output characteristics of Bjt. I have a Bjt, NPN Bjt here. Let me connect base and emitter to the component emitter mode. So after connecting base and emitter terminals to the component test port, this is how the characteristics look like. It is similar to that of the characteristic of a diode. Now let us connect a collector and emitter and see the output characteristics. Now I have connected collector and emitter terminals to the component test port, and I have applied 0 volt to the base of the transistor. Now the transistor is in cutoff region, and as a result the current flow through the transistor is 0. Now I'll increase the base emitter voltage so that the transistor starts conducting, and you can see as I increase the base emitter voltage, the transistor is switching on. More I increase, more is the current that is flowing through the transistor, and this is the output characteristic of a NPN Bjt. So you can test whether the components are working fine or not using this component test mode. And this particular model of the CRO can provide a voltage swing, input voltage swing of minus 12 volt to plus 12 volt. This type of feature is most commonly present in older CROs. Nowadays people do not use component test, the feature that is available in the CRO. That's why most of the modern CROs lack this particular feature. However, if your CRO has this particular feature, you can use this feature to obtain VI characteristics of the devices very quickly. Thank you.